imagine a group of parties who want to play a game of poker, but they don't want to do it on the global blockchain ledger. So what they can do is they can cut out some funds from the global ledger, put them into a mini ledger and operate it off-chain in a separate protocol, quasi-independently of the general blockchain protocol. And then once they are done, or maybe they detect some cheating at some point, they can just take the latest state and reintegrate it into the global blockchain ledger and then continue from this state.
This model fits extremely well with the extended UTXO model because we have natural ways to shard the stake space without sharding the ledger itself.
If I do it on layer 1, it's slow and expensive. What I'm going to do is batch something somehow, some way, and then do it in a different system where it's fast and cheap. And what I'm doing with that is I'm losing some of the security guarantees of the base layer and admitting a slight higher degree of centralization. But then I get super fast settlement, I get super low cost transactions, and potentially I may even be able to get distributed computing, meaning that instead of having the smart contracts run in a replicated system, they can run on a single node like a stake pool, and their stuff is different from the other guy's stuff. So you go from a system of capacity of whatever it is to a system of N for the totality of all the stake pools.
You can have competitiveness in the implementation. It gives you a path to a DEX. It gives you a path to interchain interoperability, and it can scale to millions of transactions per second if you want to do that. Brain dead obvious, low cost, super high return, and you leverage years of prior results and research for these things. In terms of ledger sharding, super complicated. The security of your system scales down to a third to a quarter. You have to introduce a lot of usually trusted centralized infrastructure to bootstrap it or create fail-safes as you're getting the system out. And Byzantine behavior dramatically reduces the performance of the system, dramatically. So when everybody's honest, the system is probably very fast. When you have an event, the system slows down. That's why Ghost and Phantom and these other DAG protocols didn't work out the way that people intended.
The consensus service, of course, is fast because it's a native service. And what it lets you do is build what is equivalent to new services. Just like you can write a smart contract without talking to us. You can write your own service without talking to us. And your service lives on top of the consensus service. The perennial problem in ledgers is, what do we pull down into the native layer and what do we just leave as smart contracts? We're now letting anyone pull something down to the speed of the native layer anytime they want, just by building on top of the consensus service. An AppNet is where you have your computers in your network, and it's just like a private network. You could set up your own computers, but the consensus engine is outside of your network. The consensus engine is Hedera. And so you get the full trust of Hedera, now the Hedera Council. You have the full trust of that in your network. And so the AppNet can have the privacy and the low-cost storage of a private network. But it can have the trust and the transparency, when you want to be transparent, of a public network. It's the best of both worlds, and that's what Hedera is doing.
First of all, this is a part where users still they issue transactions to the blockchain. Some are regular transactions, some are contract call transactions. The consensus committee includes them in the blockchain. But here, the difference is the following: that the consensus committee is not executing the contract calls. The only thing they do is to register the calls in the blockchain to establish the common knowledge among users that those are the calls that have been issued and need to be executed. It is a second off-chain component that would actually execute the calls. Here there would be a new set of contract committee. The selection here is similar to consensus committee. And here for a single node, that belong to the contract committee, it actually runs a VM and it fetches the contract calls from the blockchain in a deterministic way.
We see at IOTA smart contracts as multiple chains, multiple blockchains. Multiple blockchains are all anchored on the Tango.
So this is usage of data read-only inputs usage of Sigma protocols instead of simple signatures.